Ions are positively or negatively charged particles. These electrically charged particles are formed due to loss or gain of electrons and have the same electronic structure as a noble gas.
The negatively and positively charged particles attract. Metals form the positive ions, while nonmetals form the negative ions. This can be shown in this diagram. Since metals lose electrons, they have a positive valency and are located at the left-hand side of the periodic table, while nonmetals gain electrons and thus have a negative valency and are located at the right-hand side of the table. Group 0 or 8 are noble gases and therefore do not form compounds.
An ionic or electrovalent bond is a type of chemical bond formed by transfer of electrons between a metal and a nonmetal. When a piece of sodium metal is added to a flask of chlorine gas, a vigorous reaction that takes place releases a lot of energy, and sodium chloride, a common table salt, forms.
The chemical details of sodium chloride formation are similar to the formation of many other simple ionic compounds. Let's view the process of ionic compound formation of sodium chloride on the atomic scale. As soon as the metal and nonmetals make contact, a process begins. When the chlorine molecules land on the sodium surface, they separate into individual chlorine atoms, each lying next to a sodium atom. Focus on one pair of atoms to see the key events in the formation of ionic compound. Electrons transfer from the metal atom to the nonmetal atom. The sodium has 11 protons and 12 neutrons in its nucleus, and 11 electrons around the nucleus. The chlorine has 17 protons and 18 neutrons, and 17 electrons surrounding it.
18 neutrons in its nucleus, and 17 electrons surround it. The sodium atom
transfers an electron to the chlorine atom, and the particles that result attract each other and release energy. The loss of the electron converts the sodium atom to a smaller positively charged sodium ion, Na+, while the gain of the electron converts the chlorine atom into a larger negatively charged chloride ion, Cl-. Let's view this important process once more. This electron transfer process occurs between all other sodium and chlorine atoms as well. The large quantity of energy release vaporize tiny clusters of ion, and these attract others to release even more energy. These clusters eventually aggregate to coat the walls of the flask, consisting of regular array of crystalline ions
that make up crystalline sodium chloride.
Magnesium oxide is an ionic compound formed between a metal magnesium and a non-metal oxygen. Magnesium donates 2 electrons to oxygen. Thus, magnesium gets a valency of 2+, while oxygen gets a valency of 2-. Calcium chloride is another example of the same, where calcium donates 2 electrons to the 2 chlorine atoms. Thus, each chlorine gets a 1- valency, while calcium gets a 2+ valency.
Ionic compounds are usually hard and crystalline in structure, as they have atoms that are closely packed together with strong forces of attraction. The atoms form a regular symmetrical structure, which makes them hard in form.
This also results in ionic compounds having high boiling and melting points, as the strong electrostatic forces of attraction can only be broken at high temperatures.
Ionic compounds like sodium chloride are good conductors of electricity when dissolved in water. Solid sodium chloride does not conduct electricity, as it does not have any free electrons, whereas when sodium chloride is dissolved in water, the atoms dissociate and are able to conduct electricity. The aqueous sodium chloride is a good electrolyte, and this can be proven by an electrolysis experiment.
The main difference is that covalent compounds are formed by sharing of electrons between 2 nonmetals, whereas transfer of electrons from a metal to a nonmetal form ionic compounds. The differences are:
Ionic substances form giant ionic lattices containing oppositely charged ions. The oppositely charged ions are arranged in a regular way to form the giant ionic lattices. Ionic compounds often form crystals as